Today we're going to learn all about marshmallows. We're going to find out how they are made and scientifically what they are. A marshmallow is considered a simple foam, a sugary mixture with a lot of air whipped into it. What's not to love about that? Let's dive into the ingredients and see what is used to make marshmallows. At the top, you'll see that we have granulated sugar. We also have powdered gelatin. We have corn syrup, water, a mixture of cornstarch and powdered sugar, vanilla extract, and salt. A marshmallow would never be a true marshmallow without the one thing that makes marshmallows so addicting and so lovable. That is sugar. For marshmallows, we will be using a combination of two types of sugar. The first is granulated sugar. Sugar is found naturally in most plants, but it especially is found in sugarcane. Now, sugar is a sucrose, a molecule composed of 12 atoms. Oops, let's go back. 12 atoms of carbon, 22 atoms of hydrogen, and 11 atoms of oxygen. Like all compounds made from these three elements, sugar is a carbohydrate. Sugar is also soluble, which means it dissolves in water. This is the sugar that I have, and I placed it in my pot with water. It will soon dissolve. Let's move on to corn syrup. Corn syrup is a thick, odorless, colorless liquid that is denser than water. It is a solution of sugar, maltose, and other ingredients derived of cornstarch. It is used as a sweetener in foods. In our marshmallow recipe, corn syrup is used because it crystallizes at a higher temperature than granulated sugar. This will help keep our marshmallows fluffy with a smooth texture. I told you that marshmallow is considered a simple foam. We discussed how marshmallow is mostly sugar syrup with a lot of air whipped into it. But this airy sugar syrup would not stay airy and fluffy like a marshmallow all on its own. It will eventually lose air, sink, and run all over the place. To make an actual marshmallow, the sugar syrup needs something to support it, something to hold it up and keep the air from falling out. That is where gelatin comes in. Gelatin is made from long strings of amino acids, the fundamental building blocks of proteins, with a bit of hydrogen attached. These long strings, each usually a few hundred amino acid blocks long, are attracted to each other. You'll see them to the right of the screen. At room temperature, they stick together in a formation called a triple matrix. This allows each chain to bond with several others and form a complex 3D matrix. When you heat the gelatin up, these bonds between the chains loosen, turning the chemical into a liquid as they slide away from each other. You'll see this on the left. Each other isn't the only thing that these gelatin strings like to stick to. They also have an affinity for water. Because these gelatin chains have hydrogen atoms attached to their sides, the hydrogen branches can weakly bond with water. This isn't a true chemical bond. The water remains as good old water, but the oxygen atom is weakly bonded to the hydrogen atoms in just the branches of the chain. Chemists call this a hydrogen bond. If you heat the water up, this hydrogen bond will break and the water molecules will drift away. As the water cools, it slows down until this weak bond can be reestablished, linking the water to the gelatin chain again. Now, how do we get gelatin? Well, I just told you that gelatin is a protein made up of amino acids that comes from collagen. If you remember from class, collagen can be found in the connective tissue, tendons, and ligaments of mammals. It is strong. To make gelatin into something we can use for food, it is boiled out of a pig or cow parts, but bones, skin, connective tissues. You get the idea. Once it's boiled out, it is cleaned, filtered, evaporated, and ground. In America, it usually comes packaged in a powder form that can be found in the baking aisle of most supermarkets. Here's a photo of the gelatin. Now that we know what gelatin is and how it works, how exactly does it mix with the sugar to create the marshmallows? I told you that the proteins in gelatin like water. It makes the strands of proteins loosen up and spread out. When we pour the powdered gelatin into cold water, the gelatin blooms. You'll see a picture of that in my mixing bowl. This means that the bonds of the proteins are loosened and mixed throughout the water. The solid powder dissolves and the water becomes a jelly-like consistency. While the powdered gelatin and the water become a mixed jelly substance, I will heat up the corn syrup and sugar with the water in a pot. I will also add a pinch of salt to the pot. This is added for flavoring purposes. In order to evaporate the water from the sugar and make it the right consistency for marshmallows, I will bring this mixture to a boil over medium heat until it reaches 242 degrees Fahrenheit. If you're familiar with candy making, at about 240 degrees Fahrenheit, you'll get the firm ball stage. The sugar will be pliable and it will be able to briefly hold the shape of a ball. Boiling sugar also intensifies its sweetness, which is perfect for marshmallows. Once the temperature reaches 242 degrees, I will remove it from the stove. Now that we have the jelly-like gelatin and water mixture sitting in the mixing bowl ready to go, the protein strands are spread out throughout the bowl and mingling equally with the water. Coming off the stove is a very hot sugar mixture. You'll see it to the right of my screen. These two materials are about to meet for the very first time, and it is going to get sticky. I turn on the stand mixer to low as I slowly pour the hot sugar mixture into the bowl. I make sure that I am not pouring it directly onto the gelatin. Instead, I will pour the hot sugar onto the inside of the bowl and let it slowly ooze into the gelatin. While the sugar syrup is mixing, it is beginning to form a foam, creating air pockets throughout. The proteins of the gelatin are nice and warm, and they begin to flow even more freely around the mixture. Once all of the sugar is incorporated with the gelatin, I will turn the mixture on high. By turning the mixture on high, I am incorporating even more air, which causes the mixture to grow up the bowl. As I'm mixing it and whipping it, it gets higher and higher. And as it gets higher and higher, it's also getting cooler and cooler. As it cools, the bonds in the gelatin are beginning to firm up and join around the air pockets. I will continue to whip at this point, adding any desired flavors that I choose. I chose vanilla. I'll continue mixing for a couple minutes longer until the mixture is thick and sticky. At this point, the air pockets are dispersed throughout and are safe from popping or deflating because they are suspended by the newly formed bonds. I will then pour the mixture into a pre-greased baking dish, which was sprinkled with the confectioner's sugar and cornstarch. The cornstarch will help keep the marshmallow from sticking to the pan, and the sugar will make the powder a little bit sweeter. I will let the marshmallows sit out overnight, uncovered, until they settle and cool and firm up a bit. They will then be ready to roast over the fire or melt into ooey gooey goodness in your cup of hot cocoa. Thanks for listening.